In this video, we will talk about Vieta's formulas. In math, Vieta's formulas relate the coefficients of a polynomial to the sums and products of the polynomial's roots. More specifically, if the quadratic ax squared plus bx plus c equals 0 has roots r1 and r2, then the sum of the roots, or r1 plus r2, equals minus b divided by a, and the product of the roots, or r1 times r2, equals to c divided by a. Before we start working examples, let's see where the Vieta's formulas come from. Say we have quadratic ax squared plus bx plus c equals 0, and that the roots of this quadratic are x equals r1 and x equals r2. Then, the quadratic can be factored as a times x minus r1 times x minus r2 equals 0. Expanding gets us a times x squared plus the quantity of minus r1 minus r2 times x plus r1 times r2 equals 0, and further expanding gets us ax squared plus a times the quantity of minus r1 minus r2 times x plus a times r1 r2 equals 0. Now, we see that we have two equations. The first one is what we started with, or ax squared plus bx plus c equals 0. The second one is the one we just got, or ax squared plus a times the quantity of minus r1 minus r2 times x plus a times r1 r2 equals 0. Now, these two equations must be equal. Therefore, the quadratic term must line up, the linear coefficients in term must line up, and the constant term must line up. Therefore, a times the quantity of minus r1 minus r2 must equal b, and a times the quantity r1 r2 must equal c. From the first equation, we get that minus the quantity of r1 plus r2 equals to b divided by a, or r1 plus r2 equals to minus b divided by a. And from the second equation, we get that r1, r2 must equal c divided by a. And that is the proof to the Vieta's formula for quadratics. Let's work a basic example. Find the sum and product of the roots of the quadratic 2x squared plus 6x minus 7. According to Vieta's formulas, the sum of the roots equals to minus b divided by a, which in this case equals to minus 6 divided by 2, or minus 3. The product of the roots equals to c divided by a, which in this case equals to minus 7 divided by 2. Another thing Vieta's formulas can do is it can help you guess the roots to a polynomial, especially with quadratics. For example, find the solutions to the equation x squared minus 8x plus 12 equals 0. By Vieta's, we know that some of the roots, or r1 plus r2, must equal 8, and the product of the roots, or r1 times r2, must equal 12. Doing a bit of guesswork, it's not hard to see that the roots are 2 and 6. However, it is worth noting that this method of finding the roots of quadratics or other polynomials won't work as well if the polynomial has complex or non-integer roots. Now, let's work a more interesting example to see how we can use Vieta's formula in competition math. This problem is from the 2005 AMC 10 and 12. The problem reads: the quadratic equation x squared plus mx plus n has roots twice those of x squared plus px plus m, and none of m, n, and p is 0. What is the value of n divided by p? We need to find a way to relate m, n, and p. Let's see if we can use Vieta's formula to do that. Say that the quadratic x squared plus px plus m has roots r1 and r2. Then, according to the problem, the quadratic x squared plus mx plus n has roots 2r1 and 2r2. Applying Vieta's to the second quadratic, we get that the sum of the roots, or 2r1 plus 2r2, equals to minus m, and the product of the roots, or 2r1 times 2r2, which equals to 4r1 r2, equals to n. Similarly, applying Vieta's to the first quadratic, we get that r1 plus r2 equals to minus p, and r1 r2 equals to m. Let's slightly rearrange our equations. Now, from the first two equations, we see that m equals 2p, or p equals m divided by 2. From the second two equations, we see that n equals 4m. Now, we have to find n divided by p. We got n and p both in terms of m. So, n divided by p equals 4m divided by m divided by 2, which equals to 4 times 2, which equals to 8. And that is our answer. Let's now take Vieta's formula a step forward. If the cubic equation ax cubed plus bx squared plus cx plus d equals 0 has roots r1, r2, and r3, then the sum of the roots, or r1 plus r2 plus r3, equals to minus b divided by a. r1, r2 plus r1, r3 plus r2, r3 equals to c divided by a, and the product of the roots, or r1, r2, r3, equals to minus d divided by a. Let's dive straight into an example. This problem is from the 2010 AMC 10A. The problem reads, the polynomial x cubed minus ax squared plus bx minus 2010 has 3 positive integer roots. What is the smallest possible value of a? Now, we see that the coefficient of x cubed equals to 1. We're trying to find a. This invites us to use Vieta's formula. Say that our polynomial has roots r1, r2, and r3. Then, by Vieta's, the sum of the roots, or r1 plus r2 plus r3 equals to a, and the product of the roots, or r1, r2, r3, equals to 2010. Let's focus a bit onto the second equation. We know that r1 times r2 times r3 equals to 2010. Now, 2010 has the prime factorization of 2 times 3 times 5 times 67. In order to minimize the sum of the roots, we combine the 2 and the 3 to get 6, and take the roots of the polynomial as 5, 6, and 67. Therefore, a equals to the sum of the roots, or 78.